Hi, everyone. Welcome to Unit Masters Cohort 7. This is the 5th mentorship program, and we have with us today Jorge Sebastiao. He's actually spoken at the Unit conference before. He has a wealth of knowledge in the space of blockchain. I think he was connected and has just disconnected, so we'll wait for him to jump back in and then kickstart the session. Hi, Jorge. Welcome.
Yes, hi. How are things?
I love the backdrop. If that doesn't do justice to Dubai, I don't know what will.
Thank you.
All right. So I'd like to start by just doing a brief introduction of Jorge. I mean, you've got a wealth of experience under your belt. But just to summarize, Jorge Sebastiao is a name that needs very little introduction in the Middle East blockchain ecosystem. He plays in the arenas of computer and information technology, blockchain, security, and AI. He serves as CEO, CTO, CISO. On the space of security, he's an entrepreneur, board member, and advisor for a varied group of companies, bringing with him over 30 years of experience covering innovation, architecture, as well as risk management, compliance, auditing, certification, business continuity, and disaster recovery. That is a mouthful of amazing experience under your belt. He has served in sectors including telecom, oil and gas, financial, government, defense, healthcare, and education. And he is also the creator of the process known as the A6 of security, which is assess, architect, apply, administer, awareness, and agility. Jorge is based out of Dubai. He will speak to us more about the Dubai ecosystem, the regional blockchain agenda, but then also touch on what the cohort is learning this week more about, which is about consensus mechanisms. We need to understand this in depth and really get our minds around it. Welcome back, Jorge. You've been with Unit before, you've spoken at a Unit conference, and we're very, very happy to have you back so that these students and all of us can really learn from you. Just for some context, the cohort this week is focusing on terms and buzzwords in blockchain that revolve around trustless protocol, immutability, consensus algorithms, block creation and block rewards, and unpermissioned versus permissioned blockchains. The stage is yours. We'd love to hear your story. What are you so passionate about in this space of blockchain? You've been in it for such a long time. What are the recent developments? And share with us a little bit so we can get clear on the understanding of consensus mechanisms. The stage is yours, Jorge.
Okay, thank you. First, thanks very much for the opportunity to be here today. It's always helpful to assist. Yeah, my schedule tends to be a little bit crazy because there's just so many projects and activities happening around the region. I came to the region about 25 years ago. There was very little work actually in innovation or startups at that time. Actually, Dubai was pretty much just a little bit of sand and a few buildings between Dubai and Abu Dhabi. Actually, the country that was more developed at the time was Bahrain, which is about 45 minutes away. I think at the time Dubai was about 200,000, 250,000 people. Looked a bit like Las Vegas, a lot of sand. But interesting, Dubai has moved at the speed of light in terms of attracting talent, and this has happened because Dubai has created a mechanism and an ecosystem in place by providing, you can say, safe, tax-free. Tax-free does not mean free, but at least the capability for innovators and entrepreneurs to come and establish themselves. And definitely over the last 5 years, there has been a massive influx of blockchain startups, but other areas as well. A lot of work also in healthcare and other elements of technology. Just to give you an idea how busy Dubai gets, we organize something called Blockchain Week, Blockchain Month in the month of October. In the month of October alone, we had over 50 blockchain events in Dubai, only focused on blockchain, not any other industry. Some days we had up to 5 events a day. So there's quite a lot of people that have conversed in Dubai from all over the world, as far away as Puerto Rico, which hosts a lot of the Americans that are running away from the tax system. So people like Brock, Pierce, Michael Turpin, and many others. Um, so it's an exciting place to be. We have something like the Blockchain Center. I started something called EcoX or Ecosystem Connections about 4 years ago.
George, can you unmute yourself, please?
Oh, what happened? It muted by itself, or
Yeah.
okay, I don't know.
And if anyone has their mic on, please unmute yourself because there's slight disturbance from the back.
Yeah, there's a bit of noise in the back. So the thing about this entire ecosystem, the created called Ecosystem Connections, we started it 4 years ago in Dubai with about 20 people meeting weekly, and we have reached sometimes 150 people meeting weekly. So it just gives you an idea of the kind of activity that is happening. We have a meeting tonight with about 4 or 5 speakers, some on blockchain, but not always blockchain. For example, Suzanne Ho from Canada, Vancouver, is also going to be speaking about artificial intelligence as well. What I'll do is maybe I'll start with the slides. Let me see if I can find this. Just give me a second. So I'm going to be spending the next, I guess, 45 minutes or so with you. And during this time, I'll try to give a little bit of, you can say, justice to the topic of blockchain and consensus mechanisms. I try to keep this not very so deep technical, but feel free as we actually go through the elements of the presentation, and maybe we can have a few minutes for questions at the end. If you need more details or follow-up, you can use Twitter, Telegram, Instagram as to reach me. It's easy to find. On LinkedIn, I don't know, I've been at LinkedIn maximum 30,000 connections for the last 5 years, but you're welcome to connect, but it may take some time before I accept. I have a lineup of something like 3,000 people. The good thing is that in LinkedIn, about 5 to 10% of the people are fake. So as I find the fake ones, I tend to remove them from the list. So let's get onto the topic. I participate in a lot of sometimes non-profit organizations. So we do a lot of work around the world. One of them is called GBO, or Global Blockchain Organization, that was founded in Oslo. It's part of something called ADO, Alternative Development Organization. Primarily, we offer a lot of assistance and work to governments or large enterprises that want to use blockchain. We sometimes refer to blockchain as kind of a new operating system. So for me, blockchain is a technology of trust. And my background being mathematics and cybersecurity for the last 20 years, it was kind of a fairly natural evolution as well. Primarily, all these technologies that we have been introducing, you can say in IT for the last 40 years, so not just blockchain, AI, and many others, big data, etc., are primarily about creating massive disruption. And of course, as we create this disruption within, you can say today we call Web 3.0, there's some elements that did not exist before. So for example, the internet that we started 30 years or so ago as an evolution of ARPANET was not really designed for e-commerce or trust. So we tried to kind of bolt on a lot of technologies to make it more safe and to enable trust of parties. For those that know a bit of cybersecurity, maybe you've heard something called PKI, or public key infrastructure, which is kind of a technology of trust that was put on top of the traditional internet and enable you to things like do signing contracts, sending encrypted emails, digital signatures to prove that the people actually were the ones signing a specific contract. However, this is still based on a centralized authority. So that means you need to have a centralized digital certificate validation authority. When we introduced blockchain, we're really trying to eliminate this centralized certification authority. So blockchain itself, it's not something new because it actually grabbed a lot of the elements that have been around with us for many years, sometimes 20, 30 years. But these elements are known to some of us, but it packaged them in a quietly useful and creative way. So it included things like, for example, cryptography, which basically enables you to protect the contents of the data, ensure that digital signatures are verifiable and auditable. It allowed you to create this decentralized general ledger that enabled transactions to be processed across not just one node, but many nodes at the same time. Not the first blockchain, but the evolution when we went towards blockchain 2.0, we also introduced the concept known as smart contracts, and I'll try to highlight a bit of the value that the smart contracts brought to the blockchain world. And another important element was the element of consensus, which is the element is how do we validate a transaction, and how do we ensure that that transaction gets committed to the distributed decentralized ledger. Apart from those four major elements, there's many others that are actually quite important. Things like automation. So it's actually, the blockchain actually becomes a cloud computer or a decentralized cloud computer with decentralization as its own unique aspects. It has also many elements like validating the transactions to be unique, and it tries to kind of solve this problem of double spending, which I'll highlight in a second. And the nice thing about, you can say, the blockchain is that once transactions are written, they stay there for forever. Now, they can still be reversed somehow, but you'll see the reversal aspects of the transaction. So you'll have a complete history of all the corrections that were made to the data. And because of its digital signature concept, it can be used for a lot of authentication of information. And the best example of that is what we call today non-fungible tokens or NFTs, which allow you to create either validation of things like an educational degree or create art that is unique and associated with a particular individual and ensure it gets rewarded for the intellectual property that it created. Although blockchain, and we are only going to focus very much a little bit today on this thing called the protocols and the consensus mechanisms within the protocol, it is much more than that. And one has to understand that there is a infrastructure layer in which you have to have hardware and networking infrastructure that enables the blockchain network to actually work. So many components you may have heard about, things like miners, etc. Miners can actually be in mining centers, but in today's world, miners can actually be in cloud computing environments as well, like Amazon or others, so they can easily be instantiated. But that infrastructure provides, even countries like, for example, China has tried to establish China blockchain service network. And the idea behind that is to, instead of people have to paying or setting up their blockchain network, you can have like a blockchain as a service, and any organization can put their own blockchain within that, and then it supports about 4 or 5 blockchains. On top of that, you have the various network protocols, permissionless, permissioned, and this is sometimes what we refer as private or public blockchains. Things like, for example, Bitcoin is primarily a public blockchain, where things like, for example, Ethereum can be defined as both either private or public, depending on how it is configured. Today, we have actually hundreds of blockchains being executed. So a lot of work is actually being done on what we call blockchain interoperability. So technologies like, for example, Solana, Polkadot, and others enables us to have cross-chain integration, which I think is quite important and needs to be addressed. I'll spend a little bit more time, of course, on the consensus mechanisms, But then there's other layers, what we sometimes call layer 2, that enables us to create additional services on top of the base protocols. And one, for example, quite important element of that, if we look at specifically the Bitcoin network, would be the Lightning Network, which is, by being a layer 2 protocol, it enables us to extend the functionality of that base protocol to go beyond the 7 transactions per second that are enabled within Bitcoin itself, which is not sustainable as a payment delivery system. And on top of that, we have what we call the application layer. Sometimes this application layer can reside within the blockchain, but many times it's outside the blockchain. So when we put it inside the blockchain, we tend to use coding mechanism known as dApps or decentralized apps, and those execute within the blockchain. It's still very difficult today to create 100% blockchain-based technology. So you need to integrate it with the traditional systems that we have had for the last 20, 30 years. So then we have an interface, and today that interface could be, most of the cases, in a mobile, either as a web interface or as a mobile app, or being used in traditional browsers or desktop computers, tablets, or any other device. One has to understand that also we have a whole new generation of devices like IoT, Internet of Things, that where blockchain can play an extremely important element about validating the authority and the authenticity of that IoT device. So that if you're creating things like smart cities, it is important to be able to validate the data associated with that. Blockchain has gone through a lot of evolution and revolution. So you can say that blockchain 1.0, which we sometimes refer to as, for some, Bitcoin, it was primarily designed as a digital currency or store of value. However, we realized that there were some limitations on this technology, and so it has evolved. With the birth of Ethereum, we introduced blockchain 2.0 that allowed to have actually more than one type of consensus mechanism. So, for example, blockchain 1.0 was only based on what we call proof of work, a consensus mechanism that I'll address in a little while. And blockchain 2.0, we had the capability of either using proof of work or proof of stake. And I'll highlight the differences between both. But even much more important than just the consensus mechanisms was the introduction of things like, for example, smart contracts. Smart contracts allow you to actually execute code within the blockchain. You can call it like almost like a cloud environment, decentralized. But the power really associated with that is the fact that you can now create a whole new generation of applications. And the best of those examples include today what we call DeFi, or decentralized finance. And then we have even evolution of that, what we call gamify, which is gaming compliant, complementary with decentralized finance, multiverse or virtual worlds, and NFTs, and many other things. With blockchain 3.0, we introduced the concept of dApps, which are quite important, or decentralized apps. And then we had ongoing evolutions, which included, for example, being able to support things like industrial networks. Today we have enterprise-grade blockchains that can support upwards of 1 million transactions per second. So to make a long story short, we really have a multitude of blockchains, some permissioned, some permissionless, some centralized, some more centralized and decentralized. And primarily each one is trying to solve a quite specific business problem. It's not trying to say that one is better than the other. I think one has to always understand that when we use technology, a given technology cannot solve all the problems. So it's sometimes important to adapt a specific technology for things we're trying to solve. So Bitcoin has a very well-defined scope that it solves, but there are certain areas where Bitcoin is simply not providing the necessary functionality. So we have to extend that functionality through other blockchains. So all this is about really introducing massive disruption. And one of the biggest industries that obviously has been disrupted by this blockchain industry is the banking industry, we sometimes also today call fintech industry. Now, banking has been with us for a number of years. And if we look at, for example, things like the Bitcoin network can process an average of 7 transactions per second, Ethereum about 20, Bitcoin Cash about 60, and so on. However, if we look at things like, for example, the traditional Visa MasterCard network requires at least upwards of 24,000 transactions per second. Now, you're going to say, is that a lot? No, it's very little, because today the level of adoption, something like Visa or MasterCard, is about 5% around the world. So that really means we still have a lot of room for growth, and we need to have blockchain mechanisms that address this enhanced version of requirements for scalability. What do I mean by that is, for example, if you're going to be implementing successful payment systems across places like India, Africa, China, each of those has basically a 1 billion population. If we look at Muslims around the world, or we sometimes are attracted to them by providing what we call halal or Islamic finance or ethical finance. So there are about 2 million of them around the world. So if you want to provide a mechanism that will actually serve them effectively, you need to have the capability to process a much larger number of transactions per second, certainly in the upwards of 100,000 or more to be successful. One thing that is important to also note is that there's a very big difference between the traditional databases that have been with us and blockchains as ledgers. So all of this has an important impact on how we decide to implement. Blockchains are more recent to us, but databases has been with us for at least the last 30 years. And even databases themselves have evolved from being hierarchical systems to network systems to relational, object-oriented, and so on. But primarily, each one is serving a very specific mechanism. Now, here is mentioned that, for example, blockchains are slow. Some blockchains are slow. So today you can build more centralized or more effective blockchains that are actually as fast as databases, or at least almost as fast as databases. In many cases, what we're actually doing today in applications, we're actually integrating both worlds, which means that databases and blockchains have to coexist together to actually deliver an end-to-end solution for what we're trying to solve. So primarily when we talk towards decentralization, what we were trying to do is to create a series of decentralized ledgers that enable us to store transactions in, actually we sometimes call anonymous, but I think in reality we can call pseudo-anonymous, because many people refer to Bitcoin as being anonymous, but it definitely is not. So if you collect enough data, you actually being able to determine the nature and the source of the transaction. Other things that this decentralized network is trying to solve, especially with financial transactions, is the double spend problem. And a lot of the consensus mechanism is really centered around addressing this digital currency challenge and trying to address it without having necessarily a centralized authority managing it. What is also important in this mechanism is that we can establish both private or public blockchains. Each one serves a difference. For example, if you're implementing something like a government gateway, or for example, a passport control system, you are not going to be inclined as a government organization to establish a public blockchain. So a private one makes more sense. If, however, you're trying to establish an international digital currency or payment system that is served around the world, then a public blockchain definitely makes more sense, because it allows a decentralized way to interact with the transactions that are being performed in that environment. Each of these technologies has got pluses and minuses in terms of capability of processing transactions, the kind of mechanisms that are you can say, appropriate to each. So things like, for example, public blockchains today tend to focus on proof of work, although new ones are being created that also support proof of stake. So for example, Ethereum has been experimenting with proof of stake for the last 4 years, and some early releases of that, what we can call Ethereum 2.0, which eliminate a lot of the work that is being done by the miners. And in reality, this is quite important because it will create a much greener blockchain environment. And today we also have what we call hybrid blockchains that combine both public and private elements, and many of them are centered around the work that was done on Hyperledger blockchain. Within the blockchain network, the consensus mechanism is an extremely important element, because the consensus mechanism is how all the nodes of the blockchain, or sometimes the miners as we call them, establish the confirmation of a transaction. So a messaging system is established between them, and when an agreement gets made about committing that transaction to the chain, that means all the other nodes will accept that transaction as basically being validated, and now becomes part of the historical element of the blockchain network. Of course, consensus mechanisms are not new. A lot of work has been done over the last 25 years. And primarily the problems that we're trying to solve is not just about the validation of the transaction in a decentralized way. It's about having an acceptable degree of performance as we actually validate these transactions. So different consensus mechanisms will introduce much more efficient mechanisms to actually validate the transactions. So although proof of work is probably the most popular in use consensus mechanism today, much more centralized systems or proof of stake are taking over, and it's used in more modern chains. Example include Ethereum, Binance Smart Chain, and others. Even, for example, things like Ripple Network that today is being used by banking systems to do replacement for SWIFT networks. So a lot of this work is done around an algorithm that we call Byzantine fault tolerance. And the idea is to have a decentralized system establish the commitment of transaction without failure, or that there's not a single point of failure within the network, or there's no centralized authority. So this solved one of the biggest challenges that today we have in e-commerce transactions, which are based around centralized certificate authorities. So you can say that entire infrastructure is basically rendered decentralized. The importance really of consensus is that in the case, for example, of proof of work, 51% of the nodes must agree in order for the transaction to be acceptable. Now, this 51% is important, but it's also a risk as well. What do I mean by that? If we look at something like the Bitcoin network, where we have millions of nodes around the world, being able to control 51% of those nodes today is almost virtually impossible, but not 100%. You can say it's 99.99% impossible. At one stage, upwards of 55% of the nodes were actually centered in China. Now, they were operated by definitely different organizations and individuals, but if the Chinese government was to want, they could have affected the decision-making process of the nodes, since they were hosted in a specific geography. But today, since China has been moving away from Bitcoin because they saw it as a potential challenge to their national, or the launch of their national digital currency, so a lot of these nodes have moved to other locations, like, for example, Georgia, Canada, Russia, or also ex-Soviet Union countries as well. One of the things that we have as a challenge when we talk about proof of work is the fact that it's not just the issue with the 51%, is the fact that it actually consumes a lot of energy. One is to understand it's not just Bitcoin network that uses proof of work, there's many others. And some of the other networks that use proof of work don't actually have a very large number of nodes. So in many cases, a 51% attack has been attempted against other blockchains. And the way this attack has been able to be performed is simply by instantiating lots of nodes or miners in a cloud environment like Alibaba on Amazon, and then take over the network. So if you have more than 51% of the nodes, you basically can create a version of the distributed ledger truth. The more upcoming popular element of consensus is known as proof of stake. And the idea is that it is based on much less consuming of power, but specific nodes that are acting as validators. They are certifying the value of that transaction, or they're authorizing that transaction, but they're also responsible for that transaction, which means that if that transaction turns out to be fake, the staked amount that they have put will basically be forfeited back to the network. So that acts a bit like a guarantee. So not one single consensus mechanism solves all the problems. So I think today we have probably upwards of about 100 consensus mechanisms. So each one of them tends to address specific business challenges or business problems. And I'm one of those believers that technology always evolves to try to solve the problem at hand the best possible way. You know, you cannot say because I have a hammer, every problem is a nail. So I think this evolution of consensus mechanism is extremely important. So most popular today, we have things like proof of work and proof of stake. We have more advanced elements of proof of stake known as delegated proof of stake. And there is other more evolving mechanisms that have been introduced recently. When we talk about proof of work, it really involves scanning and combining all the hashes transactions into a block. But the idea is that you're trying to make those protected by the computing power of the network. And this is why we call it proof of work. That's why, for example, today when we mine a next Bitcoin or the next block in the Bitcoin network, with the typical cost of that in electricity will vary somewhere between $3,000 of electricity to upwards of $30,000 of electricity, which means that if you're actually running quite efficient mining, that means using electricity that is below probably 4 cents per kilowatt, you'd be able to efficiently pay off your investment in miners. That's why miners that provide this proof of work are extremely important in driving and controlling the networking in an efficient way. But it is also a very profitable business. So if you're mining at $3,000 a Bitcoin and the price today is 60, I think the calculations are very simple and straightforward. Now, one of the things that is happening specifically with the Bitcoin network, because of the way the algorithm was set up, is that every periods of time, the degree of difficulty of mining increases by a factor of 2. So that really means as how we progress over time, the increasing requirement to process the next block basically will have to use double the amount of proof of work as a consensus mechanism. So that means they'll use more electricity and therefore it will be much more difficult to create. That really means that the nodes that are actually driving this consensus mechanisms, where in the early days of the Bitcoin network, you could have done this on a mobile or even a laptop, Today, no, those things are centered around bigger and bigger data centers. And even beyond that, even mining nodes across data centers are being combined together in what we call mining pools so that they can actually solve the problem of getting the next valid block. Another thing that is happening in this mining is that we're using highly specialized hardware, async hardware. And this hardware is really designed and optimized to do the hashing functions required to generate the next block. So typically today, the data centers in which this is housing are much more modern facilities with quite sophisticated cooling. And of course, there's much larger ones than the ones that you see here, but it gives you the aspect of the evolution that is happening. Now, one has to understand that although proof of work was the initial most popular consensus mechanism, it was centered around the hash power that, or the mathematical challenge of generating the next block. Proof of stake is a much more lean system, not just in terms of electricity, but also in terms of the amount of transactions per second that it can actually compute. And that really means that it is able to increase the performance factor of the blockchain by a factor of 100 or 1,000 or even more. Other types of consensus mechanism, to example, proof of authority, which tends to be much more used in things like private blockchains. Now, each of these consensus mechanisms have specific pluses and minuses associated with them. Pluses in the sense that the service that they're providing to the network to validate the transactions. Minus is the risks associated with performing that function. So for example, proof of work is susceptible to the 51% attack, but this really is only a risk in certain types of low hash rate networks. So the ones with high hash rate, like for example, Bitcoin, such a 51% attack is highly improbable. And to give you an idea, up until, let's say, 1 year ago, to generate a 51% attack against the Bitcoin network for a few seconds would have cost you in the neighborhood of something like about $1 to $1.5 million for a few seconds of cloud computing environment. So this is makes it very incentivized to actually create such a type of attack. That obviously brings us to the proof of stake that is really part of Ethereum 2.0, but also other blockchains as well. But it provides a much more friendlier and efficient mechanism based on the mining, validating the transactions, but staking an amount to ensure that those transactions are approved and authorized back into the network. Interesting aspect is with the proof of stake, we'll see a lot of the miners basically disappear because we will need probably 1,000 less miners. That's number one. Number two is the computing power requirement of those miners will be much less. So instead of having very highly specialized hardware, the proof of stake is being done by much lighter nodes that can be using a very traditional cloud environment instance that we have in places like, for example, single CPU and Amazon or Alibaba environments. Then we also have proof of authority, which is primarily used for permission blockchains. And this allows us to basically ensure the validation of the transactions. One has to understand that most of the permissional blockchains suffer from the problem of decentralization, because today in something like Hyperledger network, you only need 3 nodes. So it means you can go to Amazon, start 3 nodes, and your blockchain is set up and ready to operate. That really makes a much higher risk to that environment, in terms of availability and attack against the decentralization of that network. When we talk about things like, for example, proof of stake, we have the validator networks or the validating nodes are the ones that stake and provide the consensus mechanism through an economic model. So that means, and this economic model is providing the rewards. So that's why we have things like liquidity pools that are being staked. And today you can stake, for example, Ethereum for 1 day, 1 month, 1 year, and then get anywhere from something like a month to sometimes much higher values as well. And this actually creates a whole new banking system that is actually quite important to realize that it means staking has become a big business in the decentralized finance as well as in the validation of nodes as well. Of course, the benefits associated with this enhanced consensus mechanism is it consumes much larger quantities of electricity. And this is actually quite important because we're trying to implement the sustainability goals of the United Nations. So, creating something that consumes a lot of energy, not necessarily good. Although the people that are kind of Bitcoin maximalists have found ways of answering that challenge by saying, okay, we're just using dirty energy to power the blockchain mining nodes, but we will use things like clean energy, hydroelectricity, nuclear power, or for example, in the case of more recent launch in El Salvador, using, for example, earth-produced vapor that is actually powering electricity than will power the miners. So it's much more cleaner energy. So you can say that today in the Bitcoin network, clean energy is probably somewhere between 37 to 40%. And obviously we're trying to get over the 50% to kind of make, you can say, the blockchain network consensus mechanism, proof of work within Bitcoin to be much more acceptable politically within governments and other institutions as well. It is important to always compare these two mechanisms of consensus. So if we look at proof of work, probability of mining the next block is depending on the power, where in the proof of stake is depending on the financial incentives that you provide for staking. So the higher the amount that is staked, the more of the transactions you can validate, and obviously this is much faster. The proof of work, of course, the 51% attack is susceptible in both environments. However, you can say that the proof of stake makes it less, much more less likely to happen. In the case of Bitcoin, because there is a lot more nodes, or even Ethereum, the chance of that happening is relatively small. Last key point that I wanted to obviously highlight, although I've talked primarily about proof of work and proof of stake, there's actually today hundreds of consensus mechanisms. There's proof of Tsar. I mean, I think the amount of consensus mechanism, in one of these days, I'll have to create a table that lists all of them. So each one is trying to kind of provide a unique mechanism that increases on one side the performance of the network, another one provide the highest degree possible of decentralization, as well as optimize the resources that are actually being used to validate the network. This is actually quite important, the consensus mechanism, and specifically, I would say things like, for example, proof of work or proof of stake can be used in the fintech world. But if, however, you are trying to create an industrial world with IoT devices or a smart city, with things like parking sensors, smart meat sensors, and all that. Today, even with their proof of work or proof of stake, is simply not good enough, because we need to actually validate easily upwards of 1 million transactions per second. And none of those networks have this capability today within reach. That's why a lot of work is being done on creating better and more advanced mechanisms for consensus. Now, the consensus network is really just one element in the entire architecture about providing a complete end-to-end solution within the blockchain architecture. Other elements are as important, like the smart contracts, digital wallets, cold wallets, multi-signature wallets. So there's really a lot of other components in the architecture that are as important. And although I spend more time on the consensus mechanism today, one should always realize that all of them need to be examined to take advantage of that. As we move towards a much more decentralized world and smart world, where we have things like AI validation and IoT devices, then we need to have the capability of providing both scalability and addressing that within the new environment. Some of the mechanisms have done this by doing slightly little tweaks. One example is a variation of, or a fork, you can say, of the Bitcoin network that enables, by increasing, for example, the block size and doing some tweaking, to perform a much larger numbers of transactions per second. And this is actually quite important in introducing scalability and enable you to store business and data transactions within the blockchain. Let's assume you're storing something like, for example, things like healthcare records, as an example. However, for me, the most important element of blockchain is not the technology, although the technology has to be good enough, scalable enough, decentralized enough to be able to validate the transactions, is the use cases. And today, the use cases are in a multitude of environments. You can say digital currencies and electronic payments was the first set of provable usages of this technology. But today, the variety of applications that we can develop using blockchain has expanded rapidly into things like, for example, supply chain management, smart cities, etc. For example, things like land records. So it allows us to cover much bigger scope of action, and this is actually what will actually bring value to the blockchains of the future. Now, in terms of where we are today in terms of blockchain and blockchain adoption, I still think we're in the early adopter stage. So there's still a lot of room for growth in terms of both innovation as well as the creation of a whole new generation of applications that leverage this technology. And as we do that, I think the future looks promising for people that either invest in this technology or are creating startup organizations that provide solutions within this new environment. So if we look specifically at Dubai, Dubai has committed that all its government services are powered by blockchain as of last year, and they have pretty much achieved that. Now, does that really mean that Dubai runs 100% on blockchain? No, but each government department has at least a few blockchain services implementations, whether it is the land registry, whether it's the water and electricity, and so on. So this serves as a way and as a test bed as we move forward. One of the interesting innovative systems that was done in Dubai using blockchain is the one that addresses actually the passports. So for example, if somebody happens to lose their passport, they're able to recover their digital identity within 2 to 3 hours within a short period of time. So if they need to travel or otherwise, they can do it much more quickly because it ties it with the biometric identity of the person. A lot of work has been done in Dubai and around the region to make sure that blockchain projects are as successful as possible, and by giving these blockchain projects all the necessary training and resources. So I can invite you to download this guide, which is available both in English as well as Arabic, which is how to navigate blockchain projects and how to implement them in a successful way. Simply scan the QR code and you'll be able to download the PDF document. The last part is more of kind of a note from a good friend, Brock Pierce, which is why are we actually doing all of this? In reality, what we're doing is we're trying to create a whole new generation of services that impacts the lives of citizens we're trying to serve in a positive way. And to this effect, we can say a modern definition of a billionaire is someone which can positively impact the lives of 1 billion people. And as I mentioned to you before, where are those billion people? 1 billion in India, 1 billion in Africa, 1 billion in China, 2 billion Muslims, and not a billion scattered around the rest of the world. So I do believe this disruption ahead is important and is contributing to the entire IT and business solutions that we are implementing. And I thank you for the opportunity to be with you today. And maybe if there is one or two questions, I might try to or answer them. Or if I don't have the answer for them, I definitely can get back to you through one of the social media interfaces.
George, thank you so much. That was amazing, so thorough.
So thank you very much. So I think we have quite a group of people all over the world. So I hope everybody enjoyed, depending which time zone they happen to be in. So I'm looking forward to meeting you in the future sometime, either electronically or physically. It's always better sometimes, but we try our best.
George, thank you so much for that thorough presentation. It's left everyone with a wealth of information to kind of process. I know that Paula said over here in the chat a few times that she loved slides and she wanted to know if she could have them and share them. Your slides were really
no problem. Yeah, I can create save a PDF version, and I'm happy to send you a copy via WhatsApp, and then
awesome.
You can definitely share it with them.
Thank you so much. That's awesome.
You can if the video is available later on, I'm happy to upload it somewhere.
Yes, definitely.
I have I don't know, 50, 60 videos out there as well. So I have had time to upload all of them. So usually when I have a bit of free time, I do a bunch of them at a time. So
that's great, George. We'll definitely share the video with you. We have a couple of questions that are lingering in the chat. I'll just read them out and maybe we can get into it a little bit. Typically, we used to do about 10 minutes of breakout rooms, but this presentation was so thorough and I'm sure people just want to be in this space and like get a little bit more insights from you. So I'm going to read out the questions. We'll use the 5 minutes to kind of go through anything that the audience had questions about. The first one is from Kritika. She said, in blockchain, you mentioned data is immutable, but can data be appended or can a change be added later to a subsequent block?
Yeah, the concept of the data is immutable. It simply means, okay, we have the concept of ledgers have been around with us for a number of years. That's how financial systems are implemented. So we have a ledger, which is an accountant system, and accountant system has got double bookkeeping to ensure that there's no corruption within the system. However, traditional ledgers, somebody can easily go and make entries and you'll never be able to know what happened. In blockchain, because all the blocks are chained and there is a Nash validation of the previous block, you cannot insert or modify data in the past. Now, can you still correct data? Of course you can. And the way you would have to do it is you'd have to add another, in the future block, a correction of that mistake. But the original entry of the data and the correction will actually be visible. So it's like it happens in traditional financial systems. Let's assume you made a mistake in entering the transaction. You have to enter a reversal of the transaction to put it back to the original zero value, and then one with the correct amount. And the nice thing about blockchain is that all these transactions will be visible to everyone within the blockchain. And this is why when we talk, for example, about blockchain being a new operating system, and we're trying to get blockchain to be used by governments, is that it's trying to make governments as transparent as possible. So, for example, if we have leakages, especially financial leakages within governments, those leakages would be visible. So it's not like you can just make transactions disappear that you find not convenient. Now, there is much more power than just the fact that transactions are immutable. I think even beyond this immutability, I do believe that the power of the user by the wallet, or by the way, when you have a digital wallet in blockchain, it's not the data that's with you, it's just the keys to access the data. So the wallet, it's not like a traditional wallet where the money is inside. The wallet is actually the keys to get access to the data or the money, depending on what you're referring to. But the nice power of blockchain is that, for example, you can have things like portable medical records. So as an example, which is not at all a financial transaction, which means you can go to a clinic, do tests, go to another clinic. You can only enable the kind of data that you want to be visible or shown in the new clinic. And then because that data is protected by strong encryption, it will not be available to anybody else. The second important element about this capability is, although I didn't spend too much time today on smart contracts, smart contracts are an extremely important element in blockchain because they allow us to associate with any transaction that gets performed, some code gets executed. And this is really the power that, for example, today is being implemented in NFTs. So for example, if I'm the creator of a YouTube video or a video or audio or an article or a painting, anytime that painting gets transferred to another individual or so, because I was the original creator, I can write in the smart contract, for example, that I'll be paid something like 5% of the initial value of the fees. So that really means I would get kind of, you can say, a recurring income associated with the usage of my content. So if you play my video, I get rewarded. It could be even a few pennies. But what that's really enables is for artists or content creators, writers, artists, etc., to actually being able to create a residual income for them. And the good thing is that that income comes directly into their wallets without any intermediaries. You see, there's no central authority that actually controls any of this. It's really the smart contract. When the transaction actually gets performed on the blockchain, the piece or the extra piece of code gets executed, and whatever rules are set up in this piece of code, we call it the smart contract, then the values get transferred. Now, how powerful are smart contracts? Extremely powerful. We have done an implementation with a colleague here in Dubai for the largest telecom organization in the world. For those that don't know, it's Vodafone. They have something like over 50 mobile operators, and they have hundreds, if not thousands, of suppliers in each of these opcos. Or opco is kind of a term for implementation of a telco operator in a particular jurisdiction. So they have moved a lot of their work from being paper-based contracts to smart contracts. So for example, you deal with companies like Huawei, which supplies cellular towers or mobile phones, or a company like Lenovo, which provides servers, or any other. All these are being replaced with electronically digital contracts, which means that, for example, if I order 100 servers, 99 get delivered, there's an automatic adjustment for the minus or plus one based on the delivery, instead of having an adjustment based by paper. To give you an idea, Vodafone will save in the order of $450 million just by the implementation of this smart contract technology, by saving all this paperwork. So that means a lot of these bookkeepers, you can say the other people would be probably lawyers, be a lot less involved in the disputes and the process associated with adjustment based on financial transactions.
George, that was awesome. We are over the hour mark. We are so appreciative of your time here. There are other questions in the chat, but we're going to close up, and I think I'll send them to you via chat.
Sure.
We have a Telegram group, so you're welcome to be a part of that community. Some of our speakers join in there. I'll share that with you. And thank you again. You have some really good feedback in the chat here. People really appreciate your slides. Thank you so much for being with us.
It's my pleasure to be here anytime. It's part to be of the team and contribute some value to your event or your decentralized event.
That's amazing. We're going to be doing more together, George, in the future. Thank you so much.
Okay, cheers. Have a good day.
Ciao,
All the best.
ciao, ciao. Thank
Bye-bye.
you. Bye, everyone. Thanks for being here.